Hello again, Miss Scott here. We're going to be talking about exponents now. Exponents are so much fun. They really, really are. Um, they're easy, they're fun, and they're talking about. I was supposed to touch my face about big numbers, and really nothing to not love here about exponents. Um, again, to give credit where credit is due, I am getting most of my information here, although I do know it, but it's organized better than I could organize it myself. In this book right here, everything you need to know about math in one big fat notebook. And that's, let me see, I don't know, a notes borrowed from the smartest kid in class, whoever that was. It says Workman here, so I don't even know who wrote it. Workman Publishing in New York. Okay, so we are talking about exponents. We got done talking about how we combined like terms and we used order of operations to do some of that combining of like terms and simplifying terms and so forth. So now we're going to figure out what to do with the exponents when we're combining all of that together. So first off, what is an exponent? So let's look at, oh, let's not forget to do this again today. Oh no, okay, hold on. Did I really write it crooked like that? I did. Oh my gosh. Okay, so if we're just looking at a simple number, 4 to the third power, for instance, now we learned that the 4 is a coefficient. I spelled it right this time, guys. But in terms of exponents, we also call it a base number. And then this little doohickey right here, that is the exponent. Now you may have heard the term exponential, that something has grown or something has multiplied exponentially. That means that it's not just it's not just growing at an even level, like this plus this plus this plus this plus this. It's going this times that, times that, times that. It's growing much bigger at a much faster rate than not exponentially. So exponent is the small number that is up to the the upper right hand corner of the larger number, and that larger number is either the coefficient or the base number. Okay, so when you have a 4 to the third power, you're saying that it's 4 times, remember we're not using x's, 4 times 4. Third power 3 times. Okay, so you're saying 4 times 4, which is 16, and then that's 16 times 4, which is, I want to say 54? 64. So it's 64. Whereas if you were doing what a lot of people think you do, you just take that 4 and multiply it times 3. 4 times 3 is 12. That is just straight multiplication, not exponential multiplication. This is exponential, which is what we're talking about right here. Okay? So this does not mean 4 times 3. So now let's go over some things to remember when it comes to exponents. One is that any base number without an exponent has an invisible exponent of 1. We've been talking about invisible numbers for a while. We'll go over a couple of examples in just a minute. So, in other words, if we've got a base number of 4, we're going to assume there's a little 1 right up here. Okay? And we've done that before when we have an actual variable. Let's say if our variable is x, we are assuming that there is a 1 in front of that, right? When we are looking at a parentheses, we're assuming there's a 1 in front of that. We do that a lot because, you know, if we had to put a 1 everywhere, you know, we're assuming there is one, we'd be writing a lot of 1s basically for nothing because of those properties that we talked about. Associative property, it wasn't associative property. What was it? Let's see here. You guys could probably access it faster than I could right now. It's not in here. Oh no. Oh, properties. Identity property. Oh. The identity property of multiplication states that any number times 1 is automatically itself. So 3 times 1 is going to be 3. 762 times 1 is 762. XY times 1, or the assumed one, is XY. Okay, that's the identity property of multiplication. Okay, so that's the first thing to remember. The second thing to remember, here we go. Second thing to remember, I really don't like how the red does not show up here. Let's see. Let's do blue. Any base with an exponent 0 equals 1. Any base with an exponent of 0 is 1. For instance, if you have a 4 and you have your exponent as a 0 up here, that equals 1. If you have 75 with an exponent of 0, it equals 1. Doesn't matter how big the base is. If that exponent is a 0, you're going to have a 1. It's going to be equal to 1. Okay. Number 3. You can still see there? Yeah, okay. Okay, be careful when calculating negative numbers with exponents. Be careful when calculating negative numbers We'll find out why in just a minute with exponents. So when we're talking about calculating exponents, we're talking about solving out what that exponent means. When it's like doing the math and clearing out the exponents. So, rule number one, any base without an exponent, with an exponent of 1, has an invisible, okay, back it up. Any base without an exponent has an invisible exponent of 1. That's assumed there. That is not anything that you're going to see on a generally regular basis. It's assumed that that 4, or whatever the base number is, if there's no exponent, it's actually an exponent of 1. Number 2, a base with an exponent of 0 is equal to 1. So 4 with an exponent of 0, or 4 to the 0 power, equals 1. 75 to the 0 power equals 1. Number 3, be careful when calculating negative numbers with exponents. I will show you why. It has to do with how we multiply negatives and positives and so forth. Okay, so get a good look at this. If you've got a piece of paper, write it down, pause, write, etc. Okay. So, the example of why it is that we have to be careful with negative numbers and with exponents. So we have negative 3 squared. That is the same as negative parentheses 3 squared. Of course it is. Now, that's also the same as, when we're going to break this down, parentheses 3 times 3, that's what that is, with the negative out here. And that's going to be equal to 9. Versus negative 3 parentheses squared. Wonder why that is. What do you think? This right here is the same as negative 3 times negative 3, which is also 9. But you always have to look at what is next to the exponent. In the first example, the number 3, see, this is where I messed up, because this is supposed to be negative 9. Negative 9. And the reason is because of this right here. So let me back this up. We can take this term right here, negative 3 times 3. We solve what's inside of the exponent of the parentheses, which is going to be 9. And this right here is still out here. Yeah. Let me go over that again. I knew that when I was doing it, it was not looking right to me. Okay, so we have negative 3 squared, which is the same as negative parentheses 3 squared, right? Yes, which is the same as, that negative stays right out here. Now remember, What's assumed is out here? Negative 1 times 3 squared. And this is right here, negative, because we're breaking that down, 3 times 3, which is what that is. And we're still solving inside the parentheses. Right here, the negative is still on the outside of the parentheses. 3 times 3. You good? Yeah. We're solving inside the parentheses, negative, parentheses, 9. And this is the same. Negative 1 times 9. Okay. Versus parentheses, and the negative sign is on the inside of the parentheses, 3 squared. So what this is going to break down to is negative 3 times negative 3. And that, when you multiply negative times negative and 3 times 3, you're going to get 9. Because remember, positive, positive times positive equals positive. Positive times negative equals negative. Positive times negative, negative times negative equals positive. And negative times negative equals a positive here. Okay, so always look at what is next to the exponent. In the first example, the number 3 is next to the exponent. So only the 3 is being raised to the second power. Only the 3. You see right here. In the second example, the parentheses is next to the exponent. Yeah. What? Right here. So this is the first one. These are just the negative ones that I put in there. Okay, so in the first example, the number 3 is next to the exponent. And then in the second example, the parentheses is next to the exponent. So we raise everything inside the parentheses to the second power. I would like to kind of not necessarily correct this, but demystify it. It's not necessarily what's next to the exponent as far as the parentheses. It has to do what's inside the parentheses versus outside the parentheses. When you set up your thing here, you had no parentheses. So this was the entire term. This negative was part of the term. Was not part of the term. They made it more confusing than it needed to be on this one. What we're going to do is we're just going to kind of, I'll show you as we go how to discern which way has to go, because it has really little to do with what's going on with the parentheses. So this one right here is very easy to see because we started off with the whole shebang inside the parentheses. And this one, because it wasn't all in the parentheses, we could break it down to mean negative 1 times 3 squared. We could break it down, and that's what we did. Okay, so that's how that goes. All right. So simplifying expressions with exponents. So you can simplify expressions with more than one exponent by combining the exponents. The only requirement is that the base must be the same. So it looks like this. X, which is your base, x to the a power plus, not 9, a plus x to the b power equals x to the a plus b power. Likewise, pardon me, guys. This doesn't look right to me. Okay. So yeah, we can't combine with addition if the exponent is different. So that's true. But if we're multiplying, which is what we're doing, what you do is you take the exponents and you add those. So if we're x times x, as long as the base is the same, we can do this a and b. And when it's multiplication, you're adding the exponents. So that's what that is, x a plus b. And then if you're dividing, x a divided by x to the b, that equals x a minus b. So when you're dividing numbers with exponents, you're subtracting the exponents. If you want to check this, that this works, try the long way. And I guess the way you would do that is if you had 5 squared and you're multiplying it by 5 to the 6th power. So we're taking this one right here, which is 5 times 5, and we're going to add it to 5 times 5 times 5 times 5 times 5 times 5, right? And so we're going to add these two together. Yeah, so now there's 8. 5 to the 8th power. So when dividing powers with the same base, write the base once and subtract the exponents. So if you had 7 to the 6th divided by 7 to the 2nd, you would have 7, 6 minus 2, which is also equal to 7 to the 4th. If you want to check that this works, you can do the very same thing that we did when we set up the multiplication problem and cancel stuff out. And that would look like this. So you had 7 to the 6th, so 7 times 7 times 7 times 7 times 7 times 7. We're going to be dividing via a fraction, because remember all fractions are division problems waiting to happen. And we have 7 times 7. And then we can cancel out. So we cancel this one and this one. We cancel 2, so we cancel 2 here, which leaves us with this, which is 7 to the 4th. Okay. Now we're going to try it with variables and simplify some stuff. Okay, so you have x to the squared, or x to the 2nd, times 2y times x to the 4th. Okay, so to simplify, we keep the base and add the exponents. All right. So what we're going to do here is we're going to make sure that, because remember we're doing things in numerical order, so we're going to move this to this side over here, the 2y, get it over here, so that can be listed first. Well, the 2y portion of it. And that's going to leave this right here, x squared times x to the fourth. And we know that when we combine these two, it's going to equal x to the sixth. Now, also, we have to remember that we put our letters in alphabetical order. So this is going to be, since it's multiplying, it's 2x to the sixth y. That was kind of convoluted. So I will do it slower. X to the second times 2 to the y power, to the y, 2y, and x to the fourth. Okay. So remember here, what we're doing is we're combining our like terms. This is not alike to this one. So we're going to take these because they're the x, leave the base the same, but we're going to add our exponents together. 2 plus 4 is 6. And then we have this multiplying times 2y. But we're going to put it together so that it's written the way mathematicians would write it. And that would be 2x to the sixth y. I hope that made more sense than the first time I did that. But remember, I mean, it's really not going to make any difference. You can write it y to x to the sixth, because these are all terms that are multiplication. And remember, the associative property of multiplication says it doesn't matter what order you put it in, it'll all come out the same. The only thing you have to make sure you do is this exponent will always belong to the x. The exponent does not move away from its original base. Okay, another one. 3a to the ninth divided by 7a to the fifth. Now our base numbers are a little bit different, so that's not something we have done so far. So to simplify, we take our exponents right here, and we divide them. Remember, when we divide, we take the a, but we subtract 9 minus 5. So that's a to the fourth. And we keep the base, that's the a, and we subtract the exponents. Did you see that? I flipped it. Then this becomes 3, and this is still divided by 7. And the reason we can't simplify any further is because this is not a like term to this. Remember, this is a term that does not have, now since we've transferred over, we've divided it out, or subtracted out, depending on how you look at it. We divided out this a5 from here. So we subtracted the a5 from the a9, which gave us a4 that belongs to the 3. And that left nothing under the 7. Okay, so let's do this in super slow-mo. We have 3a to the ninth divided by 7a to the fifth. Okay, we are dividing this by this. And by doing that, we are subtracting our exponents, keeping the base. Okay, so what we're going to be doing here is we're going to be basically transferring this part over to here. Okay, which makes that 3a to the fourth and leaves this now without its base and exponent. We're going to learn by doing, guys. Okay, so don't forget that you can also format this question like a fraction, which is what I did just there. It makes the solution easier to see, which that's kind of what I was doing. So when there's an exponent inside parentheses, moving on, when there's an exponent inside of parentheses and another outside the parentheses, this is called a power of a power. A power of a power can be simplified by multiplying the exponents. What? So if you have v as your variable and your exponent is a, and this is inside of a parentheses, and then you have another exponent outside your parentheses, say what? So you're raising this v to the a power, but you're then going to raise everything that's inside this parentheses to the b power. And the way you handle that is basically you just multiply your exponents rather than add. But those parentheses are what tell you that that's what you do. If you don't see parentheses, do not do that. So this now becomes v a b, v to the ab. Crazy, right? Okay. So I guess this is a mnemonic similar to please excuse my dear Aunt Sally for power of a power multiply exponents. Didn't know there was such a thing. So let's see here. Power of a power multiply exponents. We've got power of a power multiply exponents. Pop me. Pop me. Power of a power multiply exponents. Pop me. Or you could say powerful orangutans propelled multiple elephants. I personally think that that's much more trouble than you have to go through. Pop me. Okay, so now if you want to check that this works, try the long way. It's really okay. We know how to do it. We know how to multiply it out. Well, let's do it anyway. So let's say that b is a 4 and a is a 2. So that's 4 squared to the third power. So we're going to first, because of, please excuse my dear Aunt Sally, we're going to solve what's inside the parentheses first. 4 to the second power, or 4 times 4, is 16, right? And we're going to raise that to the third power. So now it's 16 times 16 times 16. Which is the same as if we had taken this and multiplied it, 4 to the 6th. Yeah, 16 times 16 times 16 is 56. And 4 to the 6th power, let's look. No, that's not 56. I did this silly mistake. Hold on. 16 to the third power is 40, 96. Never said I was a math genius, guys. I've always said that I teach math from the point of view of somebody who struggles with math. Now, 4 to the 6th power is same thing, 40, 96. So this whole thing multiplying out, pop me, it checks out. Okay. Now, moving on. Let's get a little bit more complex here. Oof, kind of getting scary. So if we take, well, in parentheses, 3x to the 7th y. Let's write down what it is I'm actually trying to say. X to the 7th, y to the 4th, in parentheses to the 2nd. Oh, what? Oh, okay. So they're breaking it down the whole thing. So they're going to apply this square second power to this, to the 3, to the x to the 7th, and to the y to the 4th. Okay. So remember, the 3 has a invisible exponent, and we're going to multiply. So 3 to the 1st times 2, and then multiply that, and there's x to the 7th times 2, and then there's y to the 4th times 2. Right? So then when we simplify it out, 3 to the 2nd is 9, so 3 times 3 is 9, right? Times x, 7 times 2 is 14, times y, 4 times 2 is 8. So we're going to do that without the multiplication signs. 9, x to the 14th, y to the 8th. I think that's the smoothest explanation has gone with this thing. Okay, so don't forget that any base without an exponent has an invisible exponent of 1. This is what we did right there. Now we're going to look at some negative exponents. That ought to be fun. Order. Okay, what about if you see a negative exponent? You can easily calculate a negative. Can you hear me when I'm talking that way? Let me try it again. What about if you see a negative exponent? You can easily calculate a negative exponent by using reciprocals. A negative exponent in the numerator becomes a positive exponent when moved to the denominator. It looks like this. So we have x to the negative m. Okay. Now, it's assumed that that's going to be over 1. Now we need to clear this negative exponent. You can't let that stand. So you have to be able to clear it by bringing it down to the denominator. So you find the reciprocal. Okay, so the reciprocal will be 1 over x to the m. So when it comes down to the denominator, it becomes a positive exponent. Okay, so let's say we've got y to the negative a, and we got to clear that negative right there, so we put it as over 1 as a fraction, and then we find that the reciprocal, put the 1 up there, and the y to the a. So now there's no more negative. Okay, there's that. So the opposite is also true. So if you see, for instance, if you see something like this where it's 1 over m to the, x to the negative m, again, you would clear it by finding the reciprocal, which would then put x to the m, not negative m, over 1. And if we had 1 over 5 to the negative 2, we would then clear it by putting this up here and that down there. It would be 5 to the second over 1, which we could actually get rid of because it's a whole number then. And 5 to the second power is 25. Okay. All right. Now, we're going to mix it up for our final, our grand finale. Okay. Let's say we have x to the 5th and y to the negative 3rd. And then we have that as a fraction with x to the negative 4th and y to the 4th. What do we do? So you're going to turn the y to the negative 3rd into a positive number by moving it to the denominator. And you're going to turn this into a positive number by moving it to the numerator. That's crazy. It's crazy, but it works. So this right here, that's negative, we're going to move it down here to the denominator so that it'll be positive. And then we're going to take this negative exponent and put it up here. So then on the top, we're going to have x to the 5th, because that stays there, times x to the 4th, no longer negative. And then on the bottom, we're going to have y to the 4th times y to the 3rd, no longer negative. Then we're going to combine our terms by multiplying it out. Remember, when we're multiplying, we just add the exponents. That's x to the 9th over y to the 7th. Woo. Now, this is a lot of convoluted information, and it's only convoluted because you haven't done it yet. This is one of those things. This is one of those concepts, guys, that you have to do. You have to do it over and over again, and then it'll make much more sense. So watch the video again, maybe once or twice, and do the homework, do the work that's assigned to you, because that is going to be the very best way that you're going to learn how these things work. By making mistakes. I mean, I keep telling you guys over and over again, make mistakes. If you're not making mistakes, then you're not trying hard enough. Make them. Make them. Because you will only learn by doing it wrong and then doing it right and then correcting your mistakes. That's how it'll finally sink into you, because this is not easy. That's what makes it fun. It's a puzzle. If puzzles are too easy, how fun could they possibly be? They have to be a challenge. They have to challenge you. Okay? But once you get it, it sticks with you for life, and it becomes a much easier thing, and it becomes one of those things that you just kind of have to have fun with. You have fun with it. You know, my 9th grade daughter brings me problems like this all the time, and because she knows I love to solve them, and I love it when I get it right. So yeah, that's what I want you to do. I want you to work on them. I want you to learn it. I want you to get it wrong so you can get it right. Okay. Those of you that are going to be working with me over the summer, we're going to be doing a lot of this. So get ready. All right.